Hello, physics friends, and welcome to 5.2 Homework Problem Solution. I'm going to be going through this worksheet, trying to do my best explaining why the answers are the way they are, so you can see me doing them in real time. Let's get started. Number one, can an object be moving forward if the force of friction is bigger than the force pulling it forward? The answer is simply yes, it can. But if you've got a box, and let's say you're pulling it with a force of 100 newtons, and then friction is opposing you of 200 newtons. All this is saying is that if this is moving, if it's moving, it just means it's accelerating this way. It's got to be slowing down. So yes, just like in the last chapter, can you move forward if there's no force pulling you forward? Yes, you're just slowing down, like throwing a ball in the air. That's all that means. So you totally can. Very possible. It means you're slowing down, though. And you will eventually come to a stop. Part number two, is the normal force always equal to the weight of an object? The answer is no, it's not. If you have a box, and let's say the thing weighs 100 newtons, if you're pulling on it at an angle, that means that the normal force is not going to be equal to the force of gravity. You're going to see that down in the very last question on this worksheet. But is the normal force always equal to? No, it's not. Letter B. When you start pulling at an angle, you're also helping, or you could be pulling downward at an angle too, and that could make the normal force more than gravity. Is static friction always less than kinetic friction? Yes. Static friction is always less than kinetic friction. Number four, which must you first overcome to get something moving? Static friction. ABAA. The problems, quantitative now. Number five, a very specific truck has this mass, and you're going this fast. It suddenly applies its brakes and it skids to a stop. How far does it travel until it comes to a halt? There's a lot going on here, a lot to unpack. And it's really important that the first thing that you do is you draw a picture. So here's this truck. It is skidding to a halt. It ends up slowing down until it rests. And you want to know how far. You know at the very beginning, its velocity is 60 miles an hour or 26.8 meters per second. And you know the velocity at the end, final velocity, initial velocity is 0. To me, this totally looks like final velocity is 0, initial velocity equals 26.8. I'm looking for the displacement. It looks to me like one of these big three equations. And every one of those big three equations has the letter A in it. So I'm going to go on a quest to find the acceleration. And once I have that, I think that I can plug it right into this equation right here. But how do we find letter A, acceleration? From your picture, here's what's going on. I've got my picture. It's really important that you put your forces that are at work here. The first force that you can never escape is gravity. Always there. You take the mass, 2250, and you multiply by 9.8, and you get 22,050 newtons. There's a normal force, a force supporting this truck. If the ground was no longer there, this truck would go falling towards the center of the earth. So the ground is actually providing some upward force. We call it the normal force. And it matches gravity in this case. And now, and I'm telling you, I could do this till I'm blue in the face. Just because your car is traveling forward, it doesn't mean that there's a force in this direction. just because it's moving forward doesn't mean there's a force in that direction. There is not a force in this direction. There is a force of friction slowing you down. That's why you are accelerating backwards. My acceleration is backwards through this because there's a force going backwards. Now, to find the force of friction, what that is, it's the coefficient times the normal force. And they give you two coefficients here. Which one do you use? Because you're sliding and because you're moving, you use the kinetic friction, 0.875. If you were standing still, if your anti-lock brakes were actually working, you would use the 0.95. Your wheels are not sliding across. They're in contact statically with the ground. So this is just what we call extraneous. I don't use it. I'm not going to use it. 0.875 times the normal force, 22,050. And I get 19,300. That's how many newtons it's. Friction is providing. Stupid side fact. I watched a YouTube video yesterday about jets, about the A-10 Warthog, and each of their engines creates 51,000 newtons. They said 51 kilonewtons of force. So I'm like, oh, 19. That's kind of in the ballpark. You know, a jet engine could provide like 2.5 of that. So just stupid side. Okay, on to the next thing. I'm looking for my acceleration. I think I can do this to find my acceleration now. Remember, I'm going to use the net force. This force and this force are canceling themselves out, and here's my net force. Because there's no force forward. There is no forward force on this problem. So my net force is 19,300, and my mass is 2250. Now I can find my acceleration. My acceleration I should maybe stick a negative in here because I'm going to say forward is positive. So that makes my acceleration negative, and that's important that it's negative in my math, so the acceleration comes out to be negative 8.58. So I stick that in there, and now I can kill this problem. Final velocity, 0. Initial velocity, 26.8 squared. 2 times negative 8.58 d. So see how the negatives are really important, because when I move this to the other side, I get a negative number, and then a negative divided by a negative is a positive. So my displacement turns out to be 41.9 meters. Boop. That seems about in the ballpark, 40 meters. That's a long, you're going fast. But believe it or not, this is what the police do. The police run this backwards. The police don't know physics. Maybe some of them do, but they have a little chart. They measure your skid mark, and then they can go backwards to figure out what speed you were going based on what the ground is and what your car is, the mass, and they can say, oh, they were going 80 miles an hour. They'll just measure your skid mark and give you a ticket, you know, for driving too fast for conditions. So, kind of fun. Next problem. Number 6. This one's way less involved. I think I would have, if I reflect upon this, I would do this question first and then do that one second in the future. What's the force of friction in this question? Force of friction equals question mark. Now, there's only one equation. The coefficient times the normal. And we have the coefficient, 0.250. Now we need to know the normal. So let's start labeling our forces. You can never escape gravity. Gravity always wins, too. And now you've got your normal force. Now, I'll tell you what the normal force is not. The normal force is not 98 in this case. And let me tell you why. Because when you take this and you break it into its x component and its y component, since this is a 45-degree triangle, the x's and y's are going to be the same. I'm going to use the sine and cosine, and this turns out to be 35.4, and so does this one, 35.4 newtons. It's if this was the case, you'd be lifting up at 35.4 and you're lifting up at 98, which means that this thing goes accelerating up. You're accelerating it off the ground. So what this normal force is, because this thing stays on the ground, staying on the ground, the normal force is 98 minus 35.4. 98 minus 35.4, which is 62.6. This is the big issue. Because now 62.6 plus 35.4 is going to equal 98, and that's the normal force, 62.6. Believe it or not, kids, if you pulled hard enough, like let's say you pulled with 500 newtons. Now this isn't 35.4, this is 354. You are pulling so hard that this thing comes flying off the ground. It's no longer staying on the ground. It's like you're pulling that thing and you're just jerking it and it's flying off the ground. That can happen. That's well within the laws of physics. But we are not pulling that hard, right? We're only pulling 35.4, so that's not enough to lift it. So this has to be 62.6. So if I take that 62.6 times 0.25, you get 15.7 newtons. Thank you all for joining me. I hope that enlightened you a little bit, and I hope that if you've got any questions, please feel free to send me an email or get a hold of me somehow. Talk to me in person. I'd love to go through this more with you. Bye.